In this lesson, we're going to explore the basic fundamentals of electricity to learn how it works, where it comes from, and how we put it to work for us in technology. If we're going to start with the basics, then we need to think small, very small. Electricity starts with the atom, these super tiny building blocks of all matter in the universe. In order to understand how electricity works, we need to know a little bit about atoms. All atoms are made up of the same three parts. In the nucleus, or center of the atom, are protons, which have a positive charge. Also in the nucleus, we find neutrons, which have a neutral charge, and orbiting the nucleus, we have electrons, which have a negative charge. We'll talk about charges in more detail, but in general, atoms are happiest when their positive and negative charges balance out. So once again, protons are positively charged particles in the nucleus of an atom. Neutrons are neutral particles in the nucleus of an atom, so they have no charge. Electrons are the negatively charged particles that zoom around the outside of the atom. When electrons start to flow from one atom to the next, we call this electricity. So back to talking about charges. An atom in balance has no charge. It has the same number of protons as electrons, so its charges cancel each other out. For instance, this helium atom has 2 protons and 2 electrons, so its charges are balanced. Atoms that have balanced charges like this are less likely to combine with other elements and are also less likely to conduct electricity because they're already in a stable, balanced state. But not all atoms work this way. Sometimes they gain or lose electrons for different reasons. If an electron is added or removed, this can cause the atom to become imbalanced or to have a charge. So if this atom has 4 blue protons and 4 gray electrons and 1 electron is lost, the atom will have a positive charge because now it has more positively charged protons than electrons. So a charge comes from an imbalance of electrons. If an electron jumps to an energized state, we call this an excited electron. This can happen when energy from an outside source is used to excite the electrons and get them moving. Now, this part gets a little bit complicated, so I'm going to try to keep it simple. Electrons surround the nucleus of an atom in layers called shells. Each shell has a specific number of electrons it can hold, and once the closest layer is full, electrons begin to fill the next farthest layer. For this example, let's look at atoms that have 2 layers or shells of electrons. The second shell wants to carry 8 electrons. If there are exactly 8, then the atom is happy. If the outer shell has less than 4 electrons, it's more likely to try to offload those extra stragglers. But if it has more than 4 electrons, then it's more likely to hold on to those extra electrons and might combine with other atoms to share some of those electrons and get a complete balanced outer shell. So these 2 behaviors, holding on to electrons or letting them go freely, give us 2 different types of materials that are very important in electronics. One of these types of materials is called conductors. These materials have few electrons in their outer shells, so they tend to let go of those extra electrons easily. All it takes is a small electrical charge to get the extra electrons excited enough to flow from one atom to the next. For this reason, conductors are used to guide and carry electricity from place to place in an electrical circuit. Things like wires and other electrical components are made from conductors because the materials allow electrons to flow through them easily. In buildings, the most common conductor used in electrical wiring is copper. But copper isn't the best conductor out there, and once an electrical circuit becomes small enough, better conductors are needed. For example, in the super tiny electrical circuits in today's phones and computers, copper wouldn't be a good choice of conductor. When it's that small, copper doesn't carry enough electricity, so other materials are used which conduct electricity much better, such as gold and silver. This is partly why cell phone companies try to recover your old phone when you buy a new one, because the old phone has valuable metals in it that are easier to recover from the old phone than they are to mine new out of the ground. So conductors are materials that allow electrons to flow through them easily. Materials that have many electrons in their outer shells are called insulators, and they do not allow their extra electrons to flow easily. For this reason, they're used in electronics to prevent electricity from flowing in certain ways. Things like plastic, rubber, and glass are good electrical insulators, so we often see them used in safety applications, like the rubber handles on tools or the plastic coating on wires. Insulators are materials that do not allow electrons to flow through them easily. For professionals working with electricity such as electricians, linemen, or electrical engineers, knowing the difference between conductors and insulators is a critical part of the job. It allows them to work safely and to make smart decisions about what materials to use for different applications.